My description here was pretty good. I think it was successful. I produced uh, eGrid, creating an empty list to start the Euclidean grid. I decided to set eGrid density equal to the events per Hubble observer times 1 point. That just turned the times 1 point turns it into a numerical evaluation, because eGrid density was defined up here as, where did I put that? It was 20, I think. Anyway, I just decided to make sure that it was a decimal. And then the what did I call it? The nested loops seem to do a pretty good job for I equals 1, I less than or equal to Euclidean grid density with I incrementing, for j equals negative I to j less than or equal to I with j incrementing. The Euclidean grid is the concatenation of the Euclidean grid, which starts out as blank, with j over the Euclidean grid density, comma, I over the Euclidean grid density. So I got that done. It seemed to generate the appropriate things. It showed up a little better when I didn't multiply by 1.0, but it does show up okay. Now the next step was awkward because we have to come up with um, Euclidean timelines, and the Euclidean timelines need to start. Well, we're going to be creating a table, and the table it's going to be similar to what I have here: table, line, group, table, line, and then instead of group, I'm going to be using eGrid, because group was the group of events associated with the Hubble particles. These are going to be events associated with a Euclidean grid, and events on the Euclidean grid that happen at the same time, the same Minkowski time, the same time for the central observer or the Euclidean observer. So this is going to be Euclidean grid, eGrid, and this is where I'm stuck because I want a 1 through 3 and then 4 through 8, I think. You know what? I'm gonna just kind of do things manually for a second before I start doing it, trying to do things a little bit more manually. So I'm going to go 1 through 3 here. 1 semicolon semicolon 3, and curly bracket, and then another line with, is it eGrid? It really should be Euclidean grid rather than eGrid. I should fix that, but I'll just call it eGrid for now. eGrid. And this time it's going to be 4 semicolon semicolon 8, right? 4, 5, 6, 7, 8. That's 5. And then it's going to go from 9 to 9, 10, 11, 12, 13, 14, 15. 15, that's 7. And then it's going to go another from 16. It's going to go 16, 17, 18, 19, 20, 21, 22, 23, 24. And so that should be interesting. But actually, I want this to be after the fold-out, because I want the fold-out of those things. Well, I could just see if it works right now. So let's put in red and have a look at those euTimeLines and see if it looks like anything at all at this point. That's interesting. Here's an error that says the expression 1 semicolon semicolon 3 cannot be used as a part specification. Did I err by putting curly brackets in here? Indeed I did. Here you can see those lines developing. 1 to 3, 4 to 8, 6, 9 to whatever. And so those are starting to develop now. We've got Euclidean or lines of constant coordinate time, where it's a Euclidean coordinate time for the central observer. So I'm going to cut and paste that down below. Well, I defined fold out down here, so well, actually I could move fold out up. That could be what I do. I'll move fold out somewhere up here. Doesn't matter. Next to LT list, because it's a function that is not used at a particular time. And then for the euTimeLines, let's see what happens if I do a fold out. It's going to look almost exactly like this line down here, except it'll be eGrid equals apply fold out, comma, eGrid, comma, 1, and then a semicolon. And I'll go ahead and take out the comment there so it'll fold out that one too. You can see the whole thing transformed. Moment of truth, I don't know whether this is actually going to cause an error. Looks like we did get an error. Yeah, that was what I was a little bit afraid of. We need to not use coordinates right on the edge of the map. So I have a couple of options here. One of them would be to just move everything up by a notch. And that might be a handy way of doing it, because that would preserve how these are lined up with the coordinates. And that would be nice. Another way would be to just kind of reduce the density, or to change the density by a small factor. So for instance, this would be very, very quick, but it wouldn't make it so that they didn't quite line up correctly with the lines. So if I just set point, say 999 here, it should fix it so we don't have those. Well, let's put this back and see if changing it to 0.999 fixes it. So actually we should be able to see the curves already, how things are curved down. Yeah, wow, that's significant curve right there. But something is strange going on, because well, of course I've got an error anyway, but for some reason it's not catching the curve in here. It's got this first one and the third one, but not the second one. Also seems actually way more smooth than I would have expected, because we've just got, don't we just have 3 points here? No, we have 3 points down here, 5 points here, 3, 5, 7, and 9, right? Yeah, 3, 5, 7, and 9. And for some reason it's not plotting this row here. Actually, I'm not convinced it's printing this line either. It doesn't look like that's I don't see anything there. It would probably help a lot if I said, say, points. What is it? Point, and also put in eGrid. That way I should be able to see the entire eGrid. But for some reason in eGrid we have a bunch of indeterminates. Why is that? You know why it is? It's because I made this less dense, and it should have been made more dense. That is probably why. Let's give it another shot. Actually, looking at it now, it's irrelevant because here's the trouble. We're looking at this thing, and whatever this thing says, that's what determines the situation. If this number is equal to this number, then we're going to have an issue. And so if j is equal to I, we're going to get an indeterminate number. So let's start I from 2, and we'll start j from minus I plus 1 to I minus 1. And see what happens. That just kind of changes the shape. Oh, yeah, well now we've got some definite, so that's our grid, and we just need to make those lines now. I think what I'm going to do, let's see, this is 1, 2, 3, 4, 5 events. Let's just change, just to see what this looks like with a little better resolution, or not really better resolution, but we're going to make events per Hubble observer 6 or 7. I'll just say 6 for now. Okay, now you can see better that, of course, this one isn't well curved. We only used 3 points for this line, 5 points for this line, 7 for this one, and 9 for this one. And you're getting a little better resolution. Let's go ahead and put one more in there. Ideally, I'd like to generate this list on the fly rather than modifying it right here. But this is 9 points. This will be 25 to 25 plus 11. And 25 plus 11 is 36, so 37. 37 to 37 plus 13. And we're going to go up here and just add one more event per Hubble observer and see how that looks. Well, we broke it. Weirdly, it's 11 numbers, but it's only 25 plus 10. And then, so this is 1 plus 2. What is it? 1 plus 2. And then this is 1 plus 3. And this is, this is 1 plus 3. This is 1 plus 3 plus 4. Then this is 1 plus 3 plus 5. And this is 1 plus 3 plus 5 plus 6. And the next one will be 1 plus 3 plus 5 plus 7. So this is all the odd numbers added together. And let's see. Okay, so that is our Euclidean coordinates in this space. And our Euclidean coordinates, our spatial coordinates, Euclidean coordinates are going to be coming out fast too. So I think what I'm going to do when I get back to this is I'm going to do the vertical coordinates. This doesn't come all the way down to the bottom here, but the Euclidean coordinates, I guess, are going to come up like this, and it's hard to tell in this coordinate system whether that's expanding or not. It almost looks like it's the spatial coordinate is not doing very much when this happens. But I would say that might be slanted, or it might even be, is it curved? I'll have to see what that looks like. Well, I think I'll go ahead and work on it now. euTimeLines and then Euclidean space lines is going to be something pretty similar to what I've got here. It'll be line, and then it'll be eGrid with double brackets, and then we're going to go through a list of points, which is going to be kind of awkward. We'll start with the middle one, which goes 2, 6, 12, and this is 2 plus 4, 6 plus 6, and then I think it'll be plus 8 from there. And I think that's the common pattern. So we'll go ahead and do this one first. This version is going to use the curly brackets, I think. And we'll go 1, comma, 1 plus 4, comma, 1 plus 4 plus 6. This is weird. Comma, 1 plus 4 plus 6 plus 8. EU spacelines. Let's just stick that in there for a second. Huh. Well, that kind of surprised me. It is shrinking. So I'm looking at a weird pattern here. I'm gonna go with I1, 2, 3. Let's see. I1, 2, 3 is gonna be I plus 4, I plus 4 plus 6, I plus 4 plus 8. Let's stick another one in there. I plus 4 plus 6 plus 8 plus 10. Could do another one past that. For the next one, I'm going to do I plus 6, I plus 6 plus 8, I plus 6 plus 8 plus 10. And we'll see if it works with I starting with 4 and 8. And I think this pattern is going to actually work. I've actually been playing with this for a little bit now. Except actually, this is odd. We're going to have line here, a table here, comma, and then we'll have another table. Is this right? We're going to have a table of a table? Hold on. Shoot. Okay, now I got the Euclidean lines all the way up in the middle. For the middle 3, I want to get it for the 4th and 8th list element, which is just I'm going to use my concatenate function to concatenate what I already have with let's see, EU space, comma, and then another table, and this table is going to be very similar to this one, except a little bit smaller. Yeah, I think it's going to be pretty similar to what we already have here, except instead of going I, 1, 2, 3, we're going to use I, 4, and 8, and we're not going to add 4 to anything. We're going to go straight to 6. I plus 6, I plus 6 plus 8, I plus 6 plus 8 plus 10, I plus 6 plus 8 plus 10 plus 12. Let's see how that works. That looks pretty good. we've got the Euclidean lines there and the Euclidean lines there. We could do another row over here, I guess. So I'm pretty much out of time, but I would like to view this without the without that nonlinear transformation. So let's pull that nonlinear transformation out, what I called the foldOut. So I'm just going to comment out the foldOut and look at the diagram and confirm that those do look like Euclidean lines before the transformation. And I am not sure if they do. Actually, I feel like I am looking at an optical illusion because this looks like it is coming closer to that line there, but I can't tell whether it really is or not. It's weird. So let's get rid of everything else. Comment out everything from there to there and see what it looks like without those things in it. And now you can see it does look like Euclidean points, but with the overlay of the other points it does not. Thanks for watching.